Many statically typed languages are great because they let you explicitly declare what types you're using. But one of the major drawbacks for this is that you have to do it. Luckily, this isn't always the case because of type arguments, which allow you to either implicitly or explicitly pass in data types as if they were just arguments for a function. Unfortunately, for a few languages, the syntax for type arguments is completely broken and most people don't even realize it. And that's because of three major issues, all of which are caused in part because the syntax for type arguments relies upon angle brackets. You might be thinking, how could this be a problem? Obviously, if it's a generic class type or a function, then any following angle brackets must signify a type argument. And if it's a variable, they're probably for comparison or something else. This is true for some languages like C++, but C++ can only get away with this because it requires every type and variable to be declared in some way before its use, which brings me to my first issue that breaks type arguments, which is that some languages don't require the user to forward declare everything before its use. Many languages allow you to use something before it's actually declared, such as JavaScript, TypeScript, C#, and Java, to name a few. TypeScript and C# are the only languages that have been able to break because of this, and I'll show you how I did it with two simple demonstrations. In C# I made a program with a function called breakEverything that has two Boolean parameters. I chose Boolean parameters because greater than and less than comparisons evaluate to Boolean values. In the main function, there's a call to the breakEverything function before it's actually declared, which means the compiler has no idea that the function takes two arguments when the call is being parsed. My intention here is to pass the results of two comparison expressions to the function, but since the comparisons are between static members of the main class that are declared after the function call, there's no way for the compiler to know if they're classes or variables ahead of time, so it just assumes they're class types and parses the two Boolean comparisons as one call to a function named foo with the type argument list containing the types bar and baz. Since there's no such function, the program doesn't actually compile, as you can see, but if I switch the order of the two arguments in the function call, it correctly parses it as a function call with two comparison expressions as its arguments, and the program successfully compiles. To fully prove that the C# compiler parses the first version of the function call as if it contains a type argument list, I changed the code below the main function in order to make the type argument list actually valid. Now, foo actually is a function that takes two type arguments, and bar and baz are actually class types. As you can see, again, it compiles. TypeScript is broken in the same way, but it could theoretically be fixed since the language requires variables to be declared before they're used. This example is slightly more alarming because it could easily be written by any programmer who may end up being subject to hours of debugging a seemingly valid function call. In this TypeScript code, once again, I call a function before its declaration, and that function also has two Boolean parameters. I had to declare the variables foo, bar, and baz before the function call because TypeScript requires it, and this would also apply to a static class member. The function call gets incorrectly parsed the same way it was in the C# example. It thinks foo is a function and bar and baz are class types, even though they are literally declared right above the function call. This is mostly just an implementation problem, probably a bug. To demonstrate the second issue that breaks type arguments, I have to go back to C#, which is the only language that I know of where this works, or doesn't work for that matter, and that is operator overloading. This isn't as big of an issue as the first one, but C#'s operator overloading allows expressions like this to be completely valid. Without operator overloading, a chain of greater than and less than expressions would be completely invalid, at least in a strongly typed language, because the first comparison in the chain would evaluate to a Boolean, which cannot be compared with a greater than or less than operator. With operator overloading, however, you can overload the greater than and less than operators to return a type other than a Boolean, such as an integer, which can be compared in this manner. All this does is basically allow for the same issue from the first example, but with only one argument instead of two. As you can see, the program doesn't compile when the left side of the expression has a less than operator and the right side has a greater than operator, but any other combination of the two operators will compile. The third issue is the least concerning because there actually is a solution that's been implemented in most languages, but I think it's actually worth bringing up because it's really annoying to deal with when you're writing a compiler, and because it's existed in C++ for the majority of its life, all the way up to 2011. And the issue is the fact that the bitwise right shift operator consists of two right-facing angle brackets. This is a problem when you're trying to parse nested type arguments, and one common example is some kind of multidimensional list. For those who don't know, compilers usually consist of three main steps: scanning, parsing, and compiling. During the process of scanning, all components of your code are identified and separated into a list of items known as tokens. This list distinguishes items such as string literals, numerical values, brackets, operators, and identifiers. When the scanner reads two consecutive right-facing angle brackets with no white space between them, it adds them to the token list as a bitwise right shift operator and continues scanning. Three consecutive right-facing angle brackets would, in most cases, be parsed as a bitwise right operator followed by a greater than operator. That means in order to parse three nested lists in C++, for example, you need to deal with three closing angle brackets, which get scanned in as a bitwise right shift operator followed by a greater than operator. You might think this issue can be fixed by a simple if statement that checks for both right shift operators and greater than operators, but it's actually much worse than that because parsing nested types requires recursion, and this issue breaks the symmetry of recursive parsing. I was able to implement my own solution by passing the number of nested parent argument lists to the type parsing function, so when the final nested child type is parsed, the function can just count how many matching right-facing angle brackets there are by adding 2 for every right shift and 1 for every greater than. There's also a special case for commas, but that's the basic idea. The implementation looks really complicated, so you can probably see why the C++ standard required a space between closing angle brackets up until C++ 11. I initially came across this issue because I was trying to make nested vector in C++ 03, and I came across a forum post from 2008 that explained the standard required spaces, but I only understood why when I was trying to create my own statically typed language. So what all these problems essentially boil down to is that some of these languages are doing too much for their syntax to be unambiguous. So my question is to all of you, what syntax should I use for my own language, the one I'm designing myself? For reference, my language is similar to C# in that it's statically typed, supports operator overloading, and doesn't require forward declarations for everything. The main difference is that it's multi-paradigm, so everything doesn't have to live inside some kind of class. The best solution I've been able to come up with requires a special kind of typecast, which is similar to a C-style cast, but it uses angle brackets instead of parentheses. You might be thinking that I'm insane because of all the problems angle brackets have caused so far, but angle brackets would normally be illegal in this situation, meaning you can naturally assume you're parsing a type here. If you can come up with a better syntax, please let me know in the comments. As always, the code for all the demos will be linked in the description.